Okay, let's start again. So pretty much I have around 6 years of experience. I work as a senior data scientist, lead the vision vertical with 9 amazing engineers at the Generative AI Center of Excellence at IDFC. So when I'm not working, I work with communities around, give sessions. I was in Singapore this year and will be traveling to Dubai and here in Cypher. And when I'm not working, pretty much I'll be traveling. So coming back to the topic, A2A protocol, and few years back, ChatGPT was released to public by OpenAI, and there was a disruption in the market. A lot of things started to evolve rapidly, where new and new models came into existence. Every now and then on LinkedIn, on X, we see companies releasing models, new frameworks are being released, and this year was a year for agents. So today, what I'll be covering majorly is what are agents. A lot of you guys might be data scientists, AI engineers, CXOs of various companies, might already have different workflows for automating tasks, reducing manpower, optimizing things. So how are they different from the agentic workflows that are coming in being? Then comes the A2A protocol released by Google. So what exactly is the A2A protocol? Why do we need that protocol? What are the key components of that protocol, which is your agent card, agent communication, and agent execution? How things become seamless after this. I'll also be covering another protocol from Anthropic, which acts as a complementary for A2A, making agentic solutions really seamless. So what I'll be talking about is how is it different from A2A, and why do we really need that? And then a combined framework on how we can leverage A2A and MCP together for our own solutions. So what basically are agents? Before I come on to this, how many of you guys are AI engineers here? Okay, few of them. So that's good. So this session will be for all of you guys who are working in the industry as an AI engineer or data scientist, or who are from the business domain. So what exactly are the agents? By the definition of it, it is basically a software which interacts with an environment it has been provided in, collects some information, and based on that information, it defines a set of tasks that it needs to perform in order to achieve a goal. That goal can be set by the human, but the task it takes and the data it uses is something AI itself decides. So let's take an example. So I work for a bank. We have customer call centers. We have various modalities by which a customer can reach out to us. It can be from emails, WhatsApp, text messages, phone calls, video calls, and whatnot. So let's think of an agent. Let's think of a person or an agent that is solving these customer queries. These information extraction or exchange can be majorly on, let's say, it's an upsell to the customer. It can be a query resolve. It can be an additional request, anything. So let's take an example where the agent interacts with the customer. It asks the relevant set of questions, retrieves the data from the bank's repository, retrieves the customer's persona. Based on that, devises a set of solutions or set of tasks that it needs to perform in order to address that query, and then has to execute those operations. It can be creating a service request. It can be asking additional information. And based on that, then it has to decide whether the end goal was satisfied or not. If yes, then it may close the request. If not, then it has to bring in human in the loop. Very autonomous, very simple problem statement, but very complex to implement from the earlier ways how we used to develop solutions. So a lot of you guys might be working in corporates where there are simple repetitive tasks now done by AI. And what we also see, since agentic AI is really a thing right now, where a lot of hiring has gone down, and a lot of repetitive tasks are now being uh, automated from AI. So what exactly is the difference between a standard AI workflow with an agentic workflow that we have? An AI workflow is basically a simple pipeline where you define a set of tasks that it needs to execute with a certain set of parameters it has and a defined objective. Yesterday, I was at a restaurant and I ordered a dessert. So let's try to link it back to the AI workflow that we have. So the chef looks at the ingredients and creates and looks at the recipe and formulates the whole dish and prepares the dish and give it back to me. Now, the same thing in an agentic environment would be where I don't tell that this is the dessert that I want to prepare. I say, okay, um, I need a dessert. And then the chef asks me, what are your preferences, looks at the ingredients, and then devises a recipe. And from that recipe, it creates the dessert and gives it back to me. Fundamentally, this is how a normal AI workflow is separated from an agentic workflow on these 4 parameters. One is decision making, where AI agents work in a very dynamic environment. They create their own set of processes. They decide what tools to use, what models to invoke, and once the output is ready, what exactly to do with the output. And then when it comes to an AI workflow, it is very static in nature, where there are predefined steps that it needs to follow and a very deterministic output. AI agents are flexible to unknown situations like the customer call center agent, where a customer can ask any query, whereas that is not the case with an AI workflow. One issue with these agents are the complexity, the sheer complexity it comes with. They are very prone to unreliable, sometimes illogical, and sometimes they go on to an infinite loop. So that is where the engineering aspect comes in. A sophisticated design is required to implement these agents, whereas AI workflows are very easier to debug, very easier to iterate, reiterate. And again comes the control, because they are autonomous in nature, harder to control as compared to the set of predefined tasks that we have in the AI workflow. That gives me a very good segue of coming to the topic, which is A2A. So what exactly an agent is, think of it as a smart assistant. Think of it as a subordinate where you give it a task. It has its own understanding of the task. Based on that, it has access to certain set of tools. And from those information, it devises set of steps and generates an output or performs a task and reports it back to you. So this is one agent. Now, in such a case, in today's world, there can be thousands of agents. It can be vendors. It can be your own personal agent. For example, let's say a Google Assistant or a Siri. Uh, it can be your cab booking agents. It can be your e-commerce agents. Let's think of a scenario where why do we really need an A2A protocol or an agent-to-agent interaction protocol? I would like to walk you through an example, a very simple real-world example that pretty much every one of you guys faces, and how A2A protocol solves it, and what are the constraints when it comes to the current implementation. A very simple scenario, I want to watch a movie. I call a friend. I say, I first check on various platforms, what movie is available, what is the venue, what are the seats, what are the timings. I call a friend, I look up at my calendar, he looks up at his calendar, and then we decide, okay, this is the one that works for both of us. We book the movie, we book the cabs to the venue, and that's it. Very normal, very realistic scenario. Now let's see when it comes to agents, how complex it becomes. So there is my own assistant, for example, it can be, just for example, I'm taking it can be a Siri, where I just say, okay, I want to watch a Marvel movie. And first it needs to understand, for booking a Marvel movie, what exactly I need to do. what exactly is the platform I need to go at, which is the friend I need to ping. It needs to understand what are my available slots. It also needs to interact with the movie agent. It needs to interact with the friend agent. Once it is being booked, it needs to interact with the cab agent. Now here's where the complexity lies. My agent does not really know what these agents perform. My agent does not really know how to interact with them. So there is a certain set of request response that, let's say, a Book My Show is doing, or let's say a Paytm is doing. Similarly, an Uber is doing. And so maybe I might have, so there are a lot of vendors in the market for agents. It can be a crew agent, or it can be a lang graph, or a small agent. My agent might be written in, let's say, the Hugging Face small agent, whereas the Paytm might be written in a crew.ai or their own framework. So I need to make sure that it interacts really well with them. And that is where the challenge comes in. So what A2A protocol does is A2A stands for agent-to-agent protocol, where it standardizes the communication framework that allows agent to interact with each other in a very consistent and a predictable way. It enables the independent agents. It can be humans, for example, my agent and my friend's agent, or any software-driven or AI-driven, the vendors that we have, to safely communicate, collaborate, and coordinate tasks. And one more beautiful thing about A2A protocol is that it abstracts out the framework on which your agent has been built on. Therefore, it enables interoperability. Now, the same scenario with A2A. Now, addressing the three key problems. What is that out of the plethora of agents that I have access to, think of agents as your DNS servers, or let's say DNS in your internet protocol, where for let's say google.com, I need to ping at 8.8.8.8. For agents, how do I really know that this is the task that it needs to perform? So the first issue is, from the list of agents, what exactly my agent can do, or what exactly these agents can do. That is where the first key component of A2A comes in, which are agent cards. They are your identity cards, very similar to how we have it in Aadhaar. But majorly what they do is three things. One is the capability discovery, where they tell that a cab booking agent can book a cab. An e-commerce agent you can buy items from there. A food booking agent, you can you can order food, you can book reservations, you can book tables. Task management, which is something very key when it comes to agents, because, for example, think of a scenario where I'm traveling to Bombay, traveling to Bangalore from Bombay, and I take up my phone and say, okay, I need to book my hotel, I need to book my flight, I need to book my cab, and I'll be spending a couple of days here, so I need to book my recreation activities and various other things on that. So this whole process takes time. It cannot be within few seconds, and our protocol cannot time out. So that is where the task management comes in, and then comes in the multimodal support, where the agent not only interacts in text, but also in images, audios, video. So this is how basically, this is a bit more technical, where this is how an agent card looks like, fairly simple, where you give a name, you give a description, you give the URL where it is hosted at, the version, the default input it expects, the default output it has to produce, and the most important thing, the skill set. Think of it as your LinkedIn, where you define what are your skills. That is where we define the skills of our agent, where it can book a cab, it can book a hotel, it can book a movie, it can reschedule a movie, it can cancel a movie. An example of it, where it's a cab agent, where I give a description about what my personal cab, it books your personal cab, and the skill set where it says, okay, book a cab, a description that, with the skill set, I can move from one location to another location. And the beautiful part is the examples, where I can specify that these are the set of intents that a user might use in order to call this agent. For example, book me a cab from X to Y, or schedule me a cab. So with these kind of information, when I give a query to my agent does a search and figures out, okay, these are the relevant agents that I need to call. Therefore, it solves my problem of what agent can do. Now, how do I communicate? Because there is a certain way in which there is a certain request response structure in which, let's say, the movie agent might be written or a cab agent might be written. So how do I make sure that they interact properly? So that is when the second key component of A2A protocol comes in, which is the messages. All the data scientists and AI engineers might be very familiar with this structure where this is how we interact with OpenAI, where we provide a role. Over here, instead of a user, it will be an agent. It will be my agent. The parts where I say, okay, this is the data type and the information. It can be the command saying that, please check with my friend when he is available for this movie. Then there'll be some meta information, message ID, task ID, and context ID. And what it does in return is gives us two critical things. One is messages, second is tasks. The task aspect is something which is very crucial when it comes to A2A. And so first, let me cover messages, where the same example where I said, okay, I need to book a movie. And okay, so it'll go to the movie agent, it'll fetch that information out, and it'll give me in a form of text saying that Marvel is let's say Avengers is available at these locations at these times. So that is where the message part comes in. Then I say, okay, book me at this location, at this venue, book me these 2 tickets. Let's say book me 2 tickets. Then the agent goes back to the movie agent, and then it again comes back with a input saying that, what I need is what timing are you looking for and what are the seat that you're looking for. That is where the state of the task comes in, where we have something called as submitted, where something called as working. For long-running tasks, it will be in working, so at least my agent knows that it has not crashed. So it still needs to wait for it to be executed. Then there is something called as input required in the example that I gave, where it is asking input from the user. Then it is completed, cancelled, and failed. Now the final thing is how these agents execute this task. That is where the final key component of A2A comes in, which is your agent executor. A very simple class where you technically where you just inherit agent executor class, and it gives you 2 abstract functionalities. One is execute, second is cancel. In execute is the place where you write your code on what exactly is the task that it needs to perform. The code in your skill set that I need to book a cab. So what it needs to do is it needs to take in these information. That is your source, destination, timing. And in the backend, it needs to call the relevant databases, do the relevant function calls, and make sure that this transaction is completed and give you back the status. That is, whether it is completed, the state that I was talking about previously. And then there is the cancel functionality, where pretty much if you want to cancel it out. So this is how the whole overall structure looks like, where now I need to book a cab. This is me. I have a client agent, which is my agent. What it does is, okay, it looks at all the agents in the list. It finds out, okay, this is the one that I need to ping. It takes the relevant set of information from me. It uses the messages to communicate with the other agent. Then the other agent performs set of tasks. If there are certain set of inputs that are required, it will revert back with these are the inputs that are required. My agent will look up, either will look up in the database and check whether these information is already present with it, or will ask me or prompt me. And once that is done, once that information has been passed along, then that is where the whole transaction gets executed. When agents interact with each other or they perform a certain set of tasks, what they are actually looking at is a certain set of information via which they can define the steps, and they can take those actions. So where does this information pretty much comes from? So in the whole scenario where I was talking about I need to book a cab, I need to book a movie ticket, I need to find my friend's availability, I need to look at my availability. So what my agent was pretty much doing is, it was looking at my calendar. It was whenever it was making a transaction, saying that, okay, I need to book a movie for these two people under this account. So it was passing that information that, I am making a booking for Shubham. Or whenever it was booking a cab, it was booking a cab for Shubham. So how is this information being passed on to? So that is where MCP plays an amazing role over here. So what exactly is MCP? So MCP stands for Model Context Protocol, where it is an open source protocol from Anthropic for connecting AI agents to external systems. Over here, the AI agent can be a software, it can be your personal assistant, external systems can be data sources, it can be tools, it can be various workflows. So what it does is it enables them with all these kind of information. So let's understand, why do we need MCP? Same old example. Shubham agent, what exactly it needs to do is it needs to connect with Google, or it needs to connect with my company's Outlook to understand, okay, these are the set of holidays, these are the set of time where I am available. Then it needs to look up with my credentials at Uber or Ola. It needs to look up at my credentials at Book My Show. It also needs to have access to my payments for it to successfully execute any kind of transaction. And the same thing also has to happen with other agents as well. So this becomes a very exponential, this becomes a blocker leading to basically having interoperability challenges, where my one agent is connected to 10 number of agents, and I need to make sure that this connection stays intact. And similarly, if I have another application, I need to perform the same thing, and that pretty much violates the dry principle that don't rewrite or don't reuse. So what MCP comes into, how MCP comes over here is, MCP does very simple task where it says, I'll be the orchestrator. What you exactly need to do is, your application should need to connect to me, and I'll be making sure that I connect to the tools. So it acts as a middle layer where now my M cross N problem becomes an M plus N problem, where my M applications needs to connect to one server or N number of servers, however I'm maintaining it out. And my N tools, it can be my Google, it can be my local storage, it can be for a corporate, it can be the AWS S3 or Azure Blob Storage or whatever you are connecting at. And so the server connects to those N tools, and it therefore becomes an M plus N integration. So there are majorly three components in an MCP, where we have the MCP client, the MCP server, and the MCP protocol. MCP client is the application that will be running on my end, that will be looking up at all the tools, resources, and prompts available to me via the server. MCP protocol is basically the communication channel via which I will be connecting to the server, getting those information, executing those calls, executing those tool calls, and performing those set of actions. And MCP server is basically my consider it as a universal connector that will be connected to all the set of tools, and it will be performing those operations or transactions or executing those codes. So what exactly is the difference between an MCP and an A2A? So MCP's work is to empower an agent from connecting it to various tool sets, various information it has. Whereas A2A focuses on connecting an agent to an agent. The primary use of MCP is to extend an agent's capability, whereas A2A focuses on a multi-agentic framework. MCP focuses on function calling, where a lot of data scientists and AI engineers might have used function calling, where they want an output in a very structured format. They want the model to execute certain set of functionalities, do certain set of function calls. So that is where MCP comes in. Whereas with A2A, it is a lot more conversational, where English text goes in, English text comes out, or let's say the modality that we are operating into. Then comes task handling. MCP is individual command focus, saying that, okay, I need to book a cab. So it needs to, let's say, update a database saying that, okay, Shubham needs, or let's look at an example of I need to book a movie ticket. So it needs to reflect it back to all the customers. So what it'll do is, once I book the movie ticket, there has to be a function call, or there has to be a call where it updates the database. That is where MCP comes in. Whereas A2A pretty much looks at handling long-running tasks with lifecycle. Discovery mechanism for MCP is via tools. Tools are basically a set of functionalities, whereas A2A is from the agent cards that I discussed before. And the implementation is majorly a very low level when it comes to MCP, and a bit higher level when it comes to A2A. So this whole example now we'll walk through with how we can achieve it a bit technically via A2A and MCP combined. So there is this agent, there is my agent. I can be running on any kind of an LLM. It can be a Gemini, GPT, Claude, or your own LLM that you want to train on, or an SLM. And I can be running on any framework, which is, it can be a LangGraph, Crew AI. Google has its own ADK, Agent Development Kit. Then it has AutoGen. And then there can be another agent. It can be the booking agent, having the similar kind of stack. Now, I need to make a booking. Let's run back the example where it is my agent running on, it can be on any model, and it can be running on any framework. And let's talk about the another company's agent. It can be the cab agent, or the Book My Show agent, or Paytm agent, or whatever. It can be running on any of the frameworks. So for my agent to understand that what is Shubham's calendar, what it will be doing is, it will be doing a call to Google and fetch my calendar. That can be the API and enterprise calls. And similarly, for the Book My Show agent, what it needs to do is, okay, it needs to update its database. So what it will be doing is, it will be connecting again to its own tools, its own connecting to its own tools, its own database via the MCP protocol, and will be updating those tasks accordingly. And so this is how the whole queue looks like, where we can maintain an agent-to-agent messaging queue. And if in that whole queue, if you want to look at the observability and CRM, or any kind of application that you want to run at, so this framework pretty much works with any kind of task that you really want to work at. For example, if I want to book a cab, what my agent will do is, it'll use this framework, it'll call the cab agent. If I want to book a movie ticket, the same framework, calling the movie ticket agent. If you want to perform a very big task, what it'll do is, it'll be utilizing the same framework with, let's say, if I want to book a full-fledged travel itinerary, or let's say travel booking, so it'll be calling multiple agents over the same queue, and will be executing those tasks in sequence. So yeah, that brings to the end of my session. Feel free to connect to me on LinkedIn, and I'm open for questions. Sure.